Desalination equipment, such as reverse osmosis membrane and multistage flush methods, which are widely used around the world, release highly concentrated seawater into the environment, resulting in toxic substances and oxygen-deficient areas. It all started with a paper published in the journal, Science of the Total Environment in January 2019. For this reason, there is a growing movement around the world to move towards ZLD or zero liquid disposal. By 2027, the market for devices that meet this demand is projected to be $9.9 billion. In Saudi Arabia, this has also become a serious problem, and Saudi has declared that it will develop a technology to eliminate the discharge of concentrated seawater into the ocean by 2030. However, it is impossible to do this with reverse osmosis, so the reverse osmosis method is becoming meaningless. One example is the reverse osmosis membrane method, which uses a membrane to filter and get fresh water, so the salt and magnesium adhering to the membrane must be discarded to make the membrane usable. In the case of impurities, the water with concentrated impurities cannot be drained, and so the membrane must be frequently discarded and replaced. In order to prevent such clogging, the reverse osmosis system can extract only 1/3 of the captured seawater as pure water. Since the remaining 2/3 are released, the salinity of the concentrated seawater released is 1.5 times higher to 4.5%. In fact, the thicker the salinity, the more likely it is that clogging will occur, so seawater with a high salinity will not be able to be treated. Considering this, it is immediately clear that it is impossible to realize ZLD with a reverse osmosis membrane device alone. Then what about the multistage flash method? In the evaporation method, the latent heat of evaporation is too large, and the required power is enormous. If it is divided to 10 stages, it is expected that the energy required will be 1/10. As I'll explain later, it's not that easy. No matter how many stages are increased, if the last remaining very salty wastewater is dumped into the sea, the increase in salinity in the surrounding waters will be worse than that of reverse osmosis. In addition, the flow of seawater throughout the device discharges rust and metal from the water pipes. The big problem with the multistage method is that it is a one-way street. In order to use boiling as a means of making steam, a number of devices with different temperatures must be connected. Since the boiling temperature varies depending on the atmospheric pressure, in the case shown in the figure, the pressure decreases from left to right. For example, if the last device is 40 degrees, it cannot be connected to the first 100-degree device. This is a one-way street. Therefore, the last 40 degrees can only be discharged. The relationship between boiling temperature and saturated vapor pressure is shown in the figure. If you look at this, it boils at 100 degrees at atmospheric pressure, but at the top of Mount Fuji, it boils at 88 degrees. This is why rice cannot be cooked well on the summit of Mount Fuji. Here, I would like to draw your attention to the vertical memory. One memory is as large as 20 kilopascals. At around 100 degrees, you can lose 20 kilopascals, but you only need to lower the temperature below 10 degrees, but when you get to around 60 degrees, you have to lower the temperature by 60 degrees to reduce 20 kilopascals. This vapor pressure is almost proportional to the amount of water vapor in the air, so in order to reduce the amount of water vapor, that is, to increase the amount of condensate, a large temperature difference is required at low temperatures. Then, as I mentioned earlier, even if the temperature is lowered by 20 degrees every stage, the amount of condensate will gradually decrease. This is a disadvantage that the lower the temperature, the lower the efficiency of water production. In the multistage method, it is difficult to increase efficiency in this way. Yabe showed that the same energy saving can be achieved by arranging two horizontal rows as shown in the middle figure, rather than stacking two rows one above the other, as shown on the left, and patented it. The details are difficult to explain, so I will omit them here, but in general, the principle is as follows. Furthermore, as shown in the figure on the right, we have patented a method that can significantly improve efficiency by making it ultra-multistage by arranging multiple propellers. This ability to multistage in one stage has created a completely new advantage. Take a look at the figure. As shown by the green arrow, the circulating water, which is pure water, that flows through the entire device was made to carry heat. The black box is a single-stage device, but warm seawater flows in from the left. Here, the temperature is set to 80 degrees, but this device does not use boiling, because boiling is dominated by atmospheric pressure. Here, we will use evaporation. It's like steaming coffee. Even at 40 degrees Celsius, steam is emitted. It is crushed with a propeller to generate steam at an even higher speed. In this way, the device became a device that is always operated at atmospheric pressure. This creates a saturated steam of 80 degrees. When this steam meets the green circulating water, it is cooled. Conversely, the circulating water is heated with the latent heat of condensation. Therefore, when the steam is cooled to 80 to 40 degrees, the circulating water is heated to 40 to 80 degrees. This circulating water heats seawater that has been cooled by evaporation. As a result, the heat of condensation heats the seawater, that is, the heat can be recovered. The seawater continues to circulate in the device, from 80 degrees to 40 degrees, then from 40 degrees to 80 degrees, and this cycle is repeated number of times. Then the salt concentration in the device increases steadily. Salt is only 20% soluble in water, so salt that exceeds 20% precipitates to the bottom of the water as shown in the photo on the upper right. When this happens, all you have to do is scoop out the salt. Compare the two methods in the figure to see the difference between the multistage method and the Yabe method. Take a moment to stare at this diagram. The upper part is the multistage method, and the lower part is Yabe method, and it is a one-stage method that has the same function as the multistage. A desalination system using this method has now been completed, and a device that processes 1 ton per day has been completed. Compare the size with 4 people. At this size, it will be possible to process 10 tons per day. Whether multiple of them will be combined to make a large system or a larger whole will depend on future tests. Since the reverse osmosis device is also a bundle of many cylindrical modules, it may be a good idea to bundle multiple modules. Then the device cost should be very low by mass production. This is the device that will save the world's water problems.